Welcome back, future elementary educators. I want to take this screencast and solve some algebraic equations so that we can learn how the concepts we've been looking at help us to solve actual equations. This is something you might be familiar with from your past. It is a linear equation. There's just an x to the first power there, so there's nothing fancy about what we're about to do. We want to solve, which means we want to find the value of x that satisfies the equation, that makes both sides actually equal. And the way we do that, so let's take us all the way back to what we did when we were kids. You would say, I want to get rid of this plus 4, and so we're going to subtract 4 from both sides. Why does that work? That works because of the addition property of equality. We know that if we add -4 to both sides of the equation, the equal things are still equal. But we get a nicer expression because the plus 4 and the minus 4 undo each other. So the left side is just 3x. The right side is 21. And then your algebra teacher probably told you that we divide by 3 to finish off the solution. Why? Because we know by the multiplication property of equality that if we multiply both sides of this equation by 1/3, the equal things remain equal. And we're looking to preserve that equality, but we get a nicer expression. The 3's cancel. The left side is just x. The right side is 7. And so this is the only value of x that solves the equation. X has to be 7. We use the addition property of equality and the multiplication property of equality to maintain equality all the way through the solution. We can only write the equal sign if we know that the quantities are equal, and we know that the quantities are equal because they started out equal, and then we used a property of equality and used a property of equality, and so x has to be 7. I will demonstrate a little further. Let's solve something a little more complicated. Let's solve 7x minus 12 equals 10x plus 9. Well, what do we do here? Here there are variables on both sides, and there are constants on both sides. So we'll move all the xy things to the right-hand side and all the constants to the left-hand side. How do we move this 7x over? Well, if we subtract 7x from both sides, then the things that are equal remain equal, addition property of equality, but we get a nicer expression. The right side has a 10x minus a 7x. Like, well, let's get rid of that 9. Let's subtract 9 from both sides. If we subtract 9 from both sides, the things that were equal remain equal, but we get a nicer expression. The right side is 3x. The left side is negative 21. And then we divide by 3. If we divide both sides by 3, the things that were equal remain equal, but we get a nicer expression. The right side is x, the left side is negative 7. And so negative 7 is equal to x. Now, you and I both know by the symmetric property that that means that x is equal to negative 7, and that's probably how we would explain it to a child. And those are the mathematical properties that are in play as we solve equations. I'll use one other property before we get a little bit weird. Let's solve 4 times n minus 3 plus 5 equals 5n plus 6. How do we solve this? Well, this is a 4 multiplied by a binomial, so you may recall that we distribute that 4 through the parentheses. We distribute it over the addition in the parentheses. That's a 4n. That's a minus 12 plus 5 equals 5n plus 6. And then we play the same game we've played before. We'll move the n things to one side and the constants to the other side. I don't want to deal with negative n's, so let's subtract 4n from both sides. The addition property of equality says that these quantities remain equal, but we get a nicer expression. The right side is n plus 6. The left side is negative 7, right? And then what? Well, we'll subtract 6 from both sides. We get a cleaner expression. We find out that n is negative 13. We use the addition property of equality. We use the addition property of equality to make sure that things that were equal remain equal throughout. One other thing. Let's pretend that you're playing a game with marbles. And in the game with marbles, if you have a blue marble and 2 green marbles, you get 16 points. If you have a green marble and 2 red marbles, you get 13 points. If you have a red marble and 2 blue marbles, you get 16 points. This is worth pausing to think about for a moment. I'll go on in about 5 seconds if you don't pause the video to think about it. Now, of course, this is algebra. This is algebra the way a 4th grader would think about algebra. There are 3 unknowns up here. But what's super cool is the following. If I had 3 blue marbles and 3 red marbles and 3 green marbles, if we just took all of these shenanigans from up here, 3 blue marbles, 3 red marbles, 3 green marbles, that would be the same as adding all of these together, wouldn't it? That'd be 45. Well, that means that 1 blue marble, 1 red marble, and 1 green marble are together worth 15 points, right? So take a look at this and this. What does that mean? If we swap out a blue for a green, it drops by 1. So blue is equal to green plus 1, which means that green plus 1 can go right there. And then we know that 3 greens plus 1 is 16. Do you know what a green has to be now? I figured that. Green marble's worth 5. And that's a fancy way to do some pretty sophisticated algebra. You're not used to doing 3 by 3 systems of equations. Haven't done that in a long time. Well, very well. I hope that these examples are helpful to you as you're preparing for class, and I wish you well as you do so.